All right, let's take a look at the PowerPoint from section 1.2, learning the difference between induction and deduction. All right. Right, there we go. In section 1.2, we're going to learn the difference between induction and deduction. So inductive reasoning and deductive reasoning. Our goals are to understand how inductive reasoning leads to making conjectures, give examples of correct and incorrect inductive reasoning, understand the difference between inductive and deductive reasoning. Inductive reasoning is the process of drawing a general conclusion by observing a pattern in specific instances. This conclusion is called a hypothesis or a conjecture. An example of inductive reasoning is consider the numbers 72, 963, 10,854, and 7,236,261, which are all divisible by 9. Add the digits in each number and make a conjecture based on the pattern. So what they're saying is to take the numbers 72, right? 7 plus 2. And that gives us 9. And if we look at the next number, 9 plus 6 plus 3, that gets us 9 plus 9, which is 18. 18 is divisible by 9. The third number is 10854. If I write little plus signs between them and add them, then I again have 18. 18 is divisible by 9. And 7 plus 2 plus 3 plus 6 plus 2 plus 6 plus 1 is 10, 27. 27 is divisible by 9. So I'm making a conjecture that if the sum of the numbers is divisible by 9, then the number itself is divisible by 9. And that's exactly what they've done. They added up each of the numbers, just like we did. Each digit of each number sums to a value that itself is divisible by 9. So the conjecture is a number is divisible by 9 if the sum of its digits is divisible by 9. One of our problem-solving techniques was the always principle, right? Keep in mind that doing inductive reasoning, you're only making an educated guess. You cannot be sure that your conclusion is true. Recall our discussion of the always principle and the counterexample principles in section 1.1. So if you can prove even one time that something we're claiming isn't true, then we can't say that it's always true, basically. All right, so it's possible to be incorrect when you're using inductive reasoning because you're making an educated guess, right? So conjecture, the incorrect conjecture here is that the number of regions is given by 2 to the power n minus 1, where n is the number of points. So in our first image, n is 1, because there's 1 point. In our second image, n is 2, because there's 2 points. In the third image, n is 3, and in the fourth image, n is 4. So the conjecture is that there are 2 to the n minus 1 regions, and it's true here in our first image. Now our conjecture says there's 2 to the power 1, because it's n minus 1 in the exponent, which is 2 regions. That checks out here. Now 2 to the 3 minus 1 is 2. That's 4 regions. 1, 2, 3, 4. That checks out here. 2 to the power 4 minus 1 is to the power 3. Says we should have 8 regions. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, that looks like a pretty good guess at what's going on. It seems like we get 2 to the n minus 1 number of regions, where n is the number of points. Let's see. Oh, they don't show us it failing. 1, 2, 3, 4, 5, 6, 7, 8. I guess we have to come up with the failing one. All right, let's do that then. All right, let's take a new region. Oh, dang it. I was trying to draw a new region with 5 dots. I know what this one looks like. I've been drawing them since grade school. Looks like a star inside of a circle. That's outside. That's my dot. Dot. Right? All right. There's my n equals 5. Now, according to the conjecture, which we're told is incorrect, says we should have 2 to the 4, right? n minus 1 regions, which is 16 regions. And I think this has been where we're going to fail. So let's try the 3. Oh, it's got it. Okay. Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We only ended up with 11 regions there. So in this example, n equals 5, we have actually only 11 regions. And that's called a counterexample. So the conjecture was that they thought that they would get 2 to the n minus 1 number of regions, where n was the number of points. But we just saw that we got 11 regions in the next image. and we should have gotten 16 according to the conjecture. So getting one example where the conjecture is wrong is called a counterexample, and that proves that that conjecture is false, is not true all the time. Deductive reasoning's definition reads, in deductive reasoning, we use accepted facts and general principles to arrive at a specific conclusion. Examples of deductive reasoning are mathematical proofs, step-by-step mathematical solutions, and using scientific laws to make predictions. Clear that. Usually we can make ourselves some little chart. For example, induction was the specific instances leading us to a general conclusion. Deduction is a general principle or accepted facts. So general facts, even, right? General to the specific. So the main takeaway from 1.2 is knowing the difference between induction and deduction. If you have several instances of someone being late and you decide this person is always late, then you're making a general conclusion based on specific instances. But you could be wrong. That person could show up on time one time and you could be wrong. And then they're not always late. They're just sometimes late. Deduction is where you take generally accepted ideas, generally accepted facts, principles, and you come to a specific conclusion, which is why it fits the mathematical step-by-step solutions, because you get to an exact answer like 4. And 4 is not a generalization, it's a specific conclusion. So often I focus on the conclusion. Is it a generalization or is it a specific conclusion? And that's how I can decide if I'm using induction or deduction.